Section 225.32 of the National Electrical Code addresses the location of service disconnecting means, stating that the service disconnecting means shall be readily accessible and shall be located at the service entrance to the building or structure. In a scenario, the high kV switches are positioned at the service entrance accessible to qualified personnel. However, to serve as disconnecting means, the switches must comply with Section 225.32b. Firstly, they must be capable of interrupting the current supplied by the service. Secondly, they should have sufficient capacity to manage the total connected load. Thirdly, they need to be approved for use as service disconnecting means. Exception number 1 to Section 225.32 provides conditions under which disconnecting means can be separated. These conditions include the disconnecting means being grouped within a readily accessible area, the disconnecting means being clearly labeled and identified, the building being under single management, and documented safe switching procedures being established and maintained. If all conditions are satisfied, separation is permissible. Applying this to the case at hand, assuming the high kV switches are located within a readily accessible substation, are clearly labeled, the building is under single management, and there are documented safe switching procedures maintained by a qualified maintenance department, the separation of disconnecting means is acceptable. The high kV switches can serve as the disconnecting means for the two separately derived systems without needing to be grouped in the same location. However, stringent adherence to Section 225.32 is vital. This includes ensuring clear labeling and identification of disconnecting means, maintaining documented safe switching procedures, and having qualified personnel execute the switching operations. Let's delve deeper into the requirements of disconnecting means as outlined in the National Electrical Code. The primary function of a disconnecting means is to isolate electrical equipment or circuits for safety during maintenance, repairs, or emergencies. It is crucial that these disconnecting means are readily accessible to authorized personnel, enabling a swift and efficient power shutoff when necessary. The phrase readily accessible implies that the disconnecting means is not obstructed and can be reached quickly without the need for tools or the removal of obstacles. In the context of high kV switches serving as disconnecting means, their location within a substation generally satisfies the readily accessible requirement, assuming that the substation itself is accessible to qualified personnel. The labeling and identification of disconnecting means are equally important. Each disconnecting means must be clearly marked to indicate the specific equipment or circuit it controls. This prevents confusion and ensures that the correct power supply is isolated. Labels should be durable and easily readable, even under adverse conditions. In the given scenario, the high kV switches should have clear and permanent labels indicating which part of the building or which specific load they disconnect. Documented safe switching procedures are a cornerstone of electrical safety. These procedures outline the step-by-step instructions for safely disconnecting and reconnecting electrical equipment. They should include precautions to prevent accidental energization, arc flash hazards, and other potential dangers. The switching procedures should be developed by qualified electrical personnel and regularly reviewed and updated to reflect any changes in the electrical system or equipment. All personnel who operate the disconnecting means should be thoroughly trained in these procedures. The safe switching procedures should cover various aspects. Firstly, verification of the absence of voltage before commencing any work. Secondly, proper grounding techniques to prevent electric shock. Thirdly, the use of personal protective equipment, or PPE, such as gloves, eye protection, and arc-rated clothing. Fourthly, communication protocols to ensure that all personnel involved in the switching operation are aware of the steps being taken. Qualified personnel are individuals who have the necessary knowledge, skills, and experience to safely operate and maintain electrical equipment. They should have a thorough understanding of the electrical system, the associated hazards, and the applicable safety procedures. The qualifications of personnel may vary depending on the complexity of the electrical system and the specific tasks they are performing. In the context of high kV switching, qualified personnel would typically include licensed electricians, electrical engineers, and trained substation operators. They should have received specific training in high-voltage switching techniques, the operation of high kV switchgear, and the applicable safety standards. The National Electrical Code provides detailed requirements for the selection, installation, and operation of electrical equipment. It is essential to consult the latest edition of the NEC to ensure compliance with all applicable codes and standards. Specifically, Article 225 covers outside branch circuits and feeders, including requirements for disconnecting means. It is important to carefully review this article and any applicable local codes to ensure that the installation meets all requirements. Furthermore, it is crucial to maintain accurate documentation of the electrical system, including single-line diagrams, equipment specifications, and switching procedures. This documentation should be readily available to qualified personnel and updated regularly to reflect any changes in the system. Regular inspections and maintenance of electrical equipment are essential for ensuring its safe and reliable operation. Disconnecting means, including high kV switches, should be inspected periodically to verify their proper functioning and to identify any signs of wear or damage. Maintenance should be performed by qualified personnel in accordance with the manufacturer's recommendations and applicable safety standards. In summary, high kV switches can be used as service disconnecting means if they meet the requirements of Section 225.32 of the National Electrical Code, including being readily accessible, capable of interrupting the current, and approved for use as service disconnecting means. Exception number 1 to Section 225.32 allows for the separation of disconnecting means if certain conditions are met, including the disconnecting means being grouped within a readily accessible area, being clearly labeled and identified, the building being under single management, and documented safe switching procedures being established and maintained. Compliance with these requirements is essential for ensuring the safety of personnel and the reliable operation of the electrical system. Now let's expand on the concept of separately derived systems and their associated disconnecting means. A separately derived system is an electrical source, such as a transformer or generator, that is not electrically connected to the main power source. These systems are often used to provide power to specific loads or areas within a building. Each separately derived system must have its own disconnecting means to isolate it from the rest of the electrical system. In the scenario described, the two transformers feeding the main distribution panels represent two separately derived systems. Each transformer has its own high kV switch, which serves as the disconnecting means for that system. The National Electrical Code requires that the disconnecting means for a separately derived system be located at the point where the system originates. This ensures that the entire system can be isolated quickly and easily in case of an emergency or for maintenance purposes. In the case of a transformer, the disconnecting means should be located in the secondary side of the transformer, as close as possible to the transformer terminals. The size and rating of the disconnecting means must be appropriate for the size and rating of the separately derived system. The disconnecting means must be capable of interrupting the maximum available fault current at that location. Fault current is the amount of current that would flow in the event of a short circuit or ground fault. It is important to calculate the available fault current to ensure that the disconnecting means is properly sized. The disconnecting means for a separately derived system must also be clearly labeled and identified. The label should indicate the source of the system, the voltage, and the amperage rating. This helps to prevent confusion and ensures that the correct power supply is isolated. In addition to the disconnecting means, each separately derived system must also have overcurrent protection. Overcurrent protection devices, such as circuit breakers or fuses, are designed to protect the system from overloads and short circuits. They should be sized and installed in accordance with the National Electrical Code. The overcurrent protection devices should be located as close as possible to the source of the separately derived system. They should also be coordinated with the disconnecting means to ensure that the system is properly protected. Coordination means that the overcurrent protection devices should trip before the disconnecting means is opened, preventing damage to the equipment. In some cases, it may be necessary to provide ground fault protection for a separately derived system. Ground fault protection is designed to detect and interrupt ground faults, which can be a serious safety hazard. Ground fault protection is typically required for systems that supply power to sensitive electronic equipment or to areas where people are likely to be exposed to electrical shock. The requirements for ground fault protection are outlined in the National Electrical Code. It is important to consult the code to determine if ground fault protection is required for a particular separately derived system. When installing a separately derived system, it is important to follow all applicable codes and standards. This includes the National Electrical Code, as well as any local codes or regulations. It is also important to consult with a qualified electrical engineer or contractor to ensure that the system is properly designed and installed. A qualified professional can help to ensure that the system meets all safety requirements and that it will operate reliably for many years to come. Proper installation and maintenance of separately derived systems are essential for ensuring the safety of personnel and the reliable operation of electrical equipment. By following the guidelines outlined in the National Electrical Code and consulting with qualified professionals, it is possible to create a safe and efficient electrical system. Now let's talk about the specific requirements in Section 225.32 of the National Electrical Code, which deals with the disconnecting means for outside branch circuits and feeders. This section is particularly relevant when considering the use of high kV switches as disconnecting means for separately derived systems. Section 225.32 requires that the disconnecting means be readily accessible. This means that it must be located in a place where it can be easily reached without the need for tools or other equipment. The disconnecting means must also be located at a readily accessible location either outside of the building or structure or inside nearest the point of entrance of the conductors. This requirement is intended to ensure that the disconnecting means can be quickly located and operated in case of an emergency. Section 225.32b specifies the type of disconnecting means that is permitted. The disconnecting means must be suitable for use as service equipment and must be rated for the voltage and current that it will be required to carry. It must also be capable of interrupting the maximum available fault current at the point of supply. This requirement is intended to ensure that the disconnecting means can safely interrupt the flow of electricity in the event of a short circuit or other fault. Section 225.32c addresses the grouping of disconnecting means. This section requires that all disconnecting means for a building or structure be grouped together in a readily accessible location. This requirement is intended to make it easier for emergency responders to quickly disconnect all power to the building or structure in the event of a fire or other emergency. However, there are exceptions to this grouping requirement. Exception number 1 allows disconnecting means to be located in separate locations if they are under single management and if documented safe switching procedures are established and maintained. This exception is particularly relevant in the scenario described where the building is under single management and has a maintenance department that maintains documented safe switching procedures. Exception number 2 allows disconnecting means to be located in separate locations if they supply different types of loads. For example, a disconnecting means that supplies power to a fire pump can be located separately from the disconnecting means that supplies power to the rest of the building. This exception is intended to ensure that critical loads, such as fire pumps, can continue to operate even if the main power supply to the building is interrupted. Section 225.32d requires that the disconnecting means be clearly labeled and identified. The label must indicate the equipment or circuit that is being served by the disconnecting means. This requirement is intended to prevent confusion and to ensure that the correct disconnecting means is operated in an emergency. Section 225.32e addresses the accessibility of the disconnecting means. This section requires that the disconnecting means be accessible to qualified personnel at all times. This means that the disconnecting means must not be blocked by equipment or other obstructions. It also means that the disconnecting means must be located in a place where it can be safely operated. In summary, Section 225.32 of the National Electrical Code provides detailed requirements for the disconnecting means for outside branch circuits and feeders. These requirements are intended to ensure that the disconnecting means is readily accessible, suitable for use as service equipment, capable of interrupting the maximum available fault current, grouped together in a readily accessible location, clearly labeled and identified, and accessible to qualified personnel at all times. By complying with these requirements, it is possible to create a safe and reliable electrical system. Now let's delve into the practical considerations of implementing safe switching procedures for high kV systems. Safe switching procedures are essential for protecting personnel and equipment from the hazards associated with high voltage electricity. These procedures should be documented, regularly reviewed, and strictly enforced. The first step in developing safe switching procedures is to identify all potential hazards. This includes the risk of electric shock, arc flash, and equipment damage. Once the hazards have been identified, the next step is to develop procedures to mitigate those hazards. These procedures should include specific steps to be taken before, during, and after switching operations. Before any switching operation is performed, it is essential to verify that the equipment is energized. This can be done by using a voltage tester to check for the presence of voltage. It is also important to verify that the equipment is properly grounded. Grounding provides a path for fault current to flow to ground, which helps to prevent electric shock. During switching operations, it is important to use proper personal protective equipment, or PP. This includes gloves, eye protection, and arc-rated clothing. It is also important to maintain a safe distance from energized equipment. The safe distance will vary depending on the voltage level of the equipment. After switching operations are completed, it is important to verify that the equipment is operating properly. This includes checking for any signs of overheating or other problems. It is also important to document a switching operation. The documentation should include the date, time, and name of the person who performed the switching operation. It should also include a description of the equipment that was switched and any problems that were encountered. Safe switching procedures should also include provisions for training. All personnel who are involved in switching operations should be properly trained in the procedures. The training should include both classroom instruction and hands-on practice. It is also important to provide regular refresher training to ensure that personnel are up to date on the latest procedures. In addition to documented procedures and training, it is also important to have proper equipment. This includes voltage testers, grounding equipment, and personal protective equipment. The equipment should be regularly inspected and maintained to ensure that it is in good working order. Finally, it is important to have a culture of safety. This means that everyone in the organization should be committed to safety. Safety should be a top priority, and all personnel should be encouraged to report any safety concerns. By implementing these practical considerations, it is possible to create a safe working environment for personnel who work with high kV systems. Remember that electrical safety is paramount, and strict adherence to established procedures is non-negotiable. Now let's address specific scenarios where exceptions to the grouping of disconnecting means might apply, particularly in the context of large facilities with multiple buildings or separately derived systems. The National Electrical Code generally requires that disconnecting means for a building or structure be grouped together in a readily accessible location. This is intended to simplify the process of energizing the entire building in an emergency situation, such as a fire. However, there are exceptions to this requirement, as previously discussed, that allow disconnecting means to be located in separate locations under certain circumstances. One common scenario where these exceptions might apply is in a large industrial facility with multiple buildings or structures. In such a facility, it may not be practical or even possible to group all of the disconnecting means together in a single location. For example, a large manufacturing plant may have several separate buildings, each with its own electrical service. It would be extremely difficult and costly to run all of the service conductors to a single location for the disconnecting means. In such cases, the exceptions to the grouping requirement may be applicable. If the facility is under single management and has documented safe switching procedures, the disconnecting means for each building can be located in separate locations. However, it is important to ensure that the disconnecting means are clearly labeled and identified, and that qualified personnel are available to operate them in an emergency. Another scenario where these exceptions might apply is in a building with multiple separately derived systems. As previously discussed, a separately derived system is an electrical source that is not electrically connected to the main power source. Each separately derived system must have its own disconnecting means. In some cases, it may be difficult or impossible to group all of the disconnecting means for the separately derived systems together in a single location. For example, a large hospital may have several generators that provide backup power to different parts of the building. The disconnecting means for each generator may be located in different locations throughout the building. In such cases, the exceptions to the grouping requirement may be applicable. If the building is under single management and has documented safe switching procedures, the disconnecting means for each separately derived system can be located in separate locations. However, it is important to ensure that the disconnecting means are clearly labeled and identified, and that qualified personnel are available to operate them in an emergency. In any situation where exceptions to the grouping of disconnecting means are being considered, it is important to carefully evaluate the risks and benefits. The primary goal is to ensure the safety of personnel and the reliable operation of the electrical system. It is also important to consult with a local electrical inspector to ensure that the installation complies with all applicable codes and standards. The electrical inspector has the final authority to determine whether or not an exception to the grouping requirement is permitted. In summary, exceptions to the grouping of disconnecting means may be applicable in certain scenarios, such as large industrial facilities with multiple buildings or buildings with multiple separately derived systems. However, it is important to carefully evaluate the risks and benefits and to consult with the local electrical inspector to ensure compliance with all applicable codes and standards.